let's see it from outside now. Last month I turned this RC car, a Land Rover Defender, into a simple FPV system and took it out to play in the snow. We had some heavy snowfall here in Romania with big snow drifts, so I had to take advantage of it. It was an amazing experience. I honestly felt like a kid again, playing in the snow with my toys. Of course, it wasn't perfect. I had a few challenges along the way. Waterproofing the electronics, dealing with video transmission system overheating, aka the VTX, and yeah, I even burned a few components while testing things. So after all that, I decided to take things a step further. This month, I'm adding a few upgrades to fix those issues and push the FPV experience even further. The goal? To turn this into a true RC driving simulator. The first step was simple. Tear everything apart. I completely disassembled the car and removed all the original electronics. I grabbed a cutter, a screwdriver and some pliers and basically ripped everything out. Everything that was on this car, gone. Straight to the trash. I wanted a clean start. From zero. Then I added a flight controller and an ESC. Just to see if it works. Just wired it up, powered it on. That's usually when you find out what's wrong. And of course, a bit of magic smoke came out. So I had to try again and figure out what I just killed. Turns out it was just a diode and a capacitor. They were rated for up to 2S, around 8 volts. I was running 4S. So yeah, they didn't like that. Quick fix. Just remove them from the circuit and everything worked. While I was tearing things apart, I noticed one of the front shocks was about to fall apart. So I pulled it out and fixed it. Now it's as good as new, I think. We'll see if the wheel stays on when I actually run it. Then I added an ExpressLRS receiver and set up the ESC. This one is a VESC, so it gives me a lot more control. I can configure it for a DC motor, set forward and reverse, adjust throttle curves, current limits, braking, even active braking. Basically, I can tune how the car actually feels to drive. Cable management on this thing is basically impossible. There's nowhere to properly secure anything. So I'm routing all the wires under the body, drilling a big hole in the back and bringing everything inside the cabin, where the flight controller is mounted. Next I mounted the flight controller using some double-sided tape. I added a 5-volt regulator to power the electronics, soldered a few XT60 connectors and got everything wired up. I also fixed an old GPS module. The antenna had come loose from a previous aerial accident. It's probably not perfect, but it should be good enough for this build. Next, I opened Mission Planner and configured Rover servos, parameters, serial ports, arming and failsafe. Then I powered up the Radio Master and took it for a quick control test. After that, I jumped into OnShip and designed the mount for the video system, including a gimbal and head tracking. And if you're not familiar with OnShip, it's actually free for hobbyists. And of course, my project is public, so you can copy it and print it yourself if you want. Link in the description. And honestly, head tracking is one of the coolest things in FPV. It lets you control the camera just by moving your head. Look left, the camera follows. Look up or down, same thing. So after finishing the design in OnShip, I jumped over to my trusty Bambu Lab printer and printed it out. And after quite a few design, print, repeat cycles, this is what I ended up with. Next, I assembled the printed parts together with the video system and the gimbal. I added a fan, used probably a bit too much hot glue, shoved all the wires through the car, hooked everything up to power and the flight controller, and powered it on. After a few runs with the car and some fun, a problem I had before, especially in freezing temperatures, came back. The video system overheated. Again. Even with the fan running, which clearly means it's way too small, and I need something much bigger. And there was another problem. The mount was too tall, so the camera was sitting way too high. I needed to somehow lower it to get a better view. So yesterday I tried the car, but the VTX got really hot, and I'm thinking to add another fan in order to cool it down better. So I found a little fan and I'm trying to add it somehow to the setup here. So I have two options. I have this fan which is 24 volts and this one which is 12 volts, and it's much bigger. So let's do a quick test. And now it's at 8.4. Let's go up to 14. Man, it will blow up the entire car. And now with a beefier fan, how on earth am I supposed to fit this inside the car? It should fit, actually fit. First attempt, I mounted it on the side and glued it in place. But once I tried to fit it inside the car, it just wouldn't go in. The center console was in the way. I thought about cutting it, but there wasn't enough space to do that without taking the whole car apart again. So the only option left was to move the fan to the bottom and remove the driver's seat. With a bit of brute force, a screwdriver and some broken plastic, I made it happen. And after that, it was Dremel time. To open up the bottom so the fan could actually pull fresh air from outside. And the result was pretty awesome. The seat was gone and the opening was nicely enlarged, ready for the new fan to pull in fresh cold air from outside. So it was time to run some tests to see if it still overheats and if the camera position is actually better now. So I took it out and yeah, that's how I had my first crash. I'm starting to think the cat might have had something to do with that. Maybe not. And now, let's go on a little adventure and check on my buddy Roger in the greenhouse, just to make sure he's doing a good job. Okay, left. Right. Whoa, that was close. Almost hit that pipe. Full throttle. The left again, making sure we give way. And finally, we made it to the greenhouse. Looks like he's throwing sand all over the place. And yeah, I really don't want that inside the car. So I'm getting out of here and heading back to finish the build, adding the steering wheel, the shifter and the pedals, and turning this into a proper simulator. But before we do that, let's add some stickers, you know, for better aerodynamics. I'm kidding. Since I'm trying to keep this on a budget, I got the steering wheel from Romania's version of eBay, OLX. The wheel setup itself is super simple. Clamp the base to the desk, attach the wheel, mount the shifter, plug everything in. Connect the USB to the laptop. And now comes the interesting part. How do we get those inputs from the wheel to control the car? During my research, I was trying to figure out if there's any way to convert a USB joystick, like this wheel, into something an ExpressLRS system can understand. And that's when I found this awesome project, which basically made this whole build possible. Link in the description. Now, at the time I was doing these tests, I forgot to record the actual setup screen, so I'm showing it now without being connected. And I'll make a separate video going into more detail. But the idea is pretty simple. The app gives you a local web interface where you select the serial port for the ExpressLRS module, pick your USB joystick, and then connect everything together using a graphical interface, kind of like Node-RED. Hit save, and that's it. Your wheel controls are now driving the car. And after that, I just kept driving. Played around for a few hours until it got dark and I couldn't see anything anymore. I even taped a flashlight to the car so I could keep going at night until the battery died. So I had to call it a day. and plan the next adventure, out in the wild, in the forest near my garage. And now I'm heading out of the yard, straight towards the forest, where we are about to explore the wild. As you can see, I also added telemetry data, basically an OSD overlay on top of the video feed. And it's actually really useful. You get battery voltage, in this case around 15.9 volts, the energy used so far in milliamp hours, the current draw about 2 amps, distance from home, GPS coordinates, number of satellites, heading, ground speed, and even video system stats like latency, bitrate, and signal quality. One really cool thing here is the artificial horizon. Because the camera is stabilized with a gimbal, it's actually hard to tell how much the car is tilting over bumps. But if you watch the dashed line in the center of the image, you can really see how uneven the terrain actually is. After a long run through bushes, weeds, and all kinds of obstacles, I eventually got stuck. So my buddy Roger had to come in and tow me back to the garage. Thanks for watching, and if you want to see more builds like this, hit subscribe.